Hi, thanks for watching today's presentation on deploying highly scalable and secure mobile and web apps on the Azure App Service platform. I'm Stefan Shakow, one of the folks who works on Azure App Service. And today I'm going to walk through with you one of the really powerful and relatively new features of our platform that you can use with both web apps and mobile apps today, and in the not too distant future, also with API apps. So specifically what I'm going to walk through with you is a feature called App Service Environments. Now, App Service Environments, sometimes referred to as ASEs, just because it's a bit of a mouthful, bring two really powerful capabilities to the apps on the Azure App Service platform. First off, we've built App Service Environments to enable customers who need to run really ultra-high scaling scenarios. And what we mean by that is customers who have demands sometimes in excess of tens of thousands of RPS that need to be sustained for things, for example, like voting applications. And then in addition to that, we also support high security options that let you deploy your apps, and specifically your app service environments, directly into your own virtual network. And the reason why that's really incredibly useful is it gives you a lot more control over both inbound and outbound traffic rules so that you can be very intentional in setting up fine-grained access over how network communications flow. And the great thing about it is that even though we built all this into app service environments, you still get all of the great features of the overall Azure App Service. So everything you know and love today about, for example, deployment slots or source code control integration, all of that is still available to you when you run your apps inside of app service environments. So let's talk a little bit about the high scale scenario. So we've gone out and we've done perf benchmarking with apps running on app service environments. And you can see here, in terms of the numbers, we've been able to benchmark up to around 25,000 RPS for standard HTTP traffic, as well as around 20,000 RPS for SSL traffic. And with those kinds of numbers, what we're able to do is go to customers and talk about scenarios, like I said, voting applications being a classic one, where you need to support really high burst loads in terms of RPS rates for a relatively short period of time. And what we're able to do is we're able to walk customers through deploying multiple instances of their apps using multiple app service environments, and you just scale out basically in cookie cutter fashion by setting up as many apps and app service environments as you need to sort of reach the desired RPS rate that you're trying to sustain. Also, interestingly, even ourselves internally, we make use of app service environments in a similar manner. So as you can imagine, we have a very large global footprint for our service. And one of the more mundane but very high scale traffic requirements we have is that we need to be able to monitor literally hundreds of thousands of sites and applications and individual scale units. And what we do internally is we actually run part of our monitoring infrastructure on app service environments. And that makes it very easy for us to be able to stamp out extra capacity as we need it and just scale out in each of the different Azure regions and keeping in front of our scaling requirements. So I've got here today a simple demo of how you can set up multiple instances of your app in an app service environment and string it together so that you can have as many instances as you need running. Now, the app itself is very straightforward. It's a simple MVC app. You're basically seeing the front end, which is written using MVC 5, and it talks out the back end to a web API. The interesting thing, though, is going to be how we set up multiple instances of the application that are serving this domain name, which is www.scalableasedemo.com. So real quick, let's take a look at what things look like when I do an NS lookup, which I did ahead of time here, and you can see that the vanity domain, Scalable ASE Demo, has an alias that points to a domain within trafficmanager.net. So that's the first sort of piece of how you put things together here. You plan up front to string together two or more instances of your app, and ergo two or more app service environments, all within the scope of a single Azure Traffic Manager profile. Now, to show that Azure Traffic Manager profile in a little bit more detail, I've already got pulled up a PowerShell window, and in it, I loaded the Azure Resource Manager version of my Traffic Manager profile. So just dumping out sort of the basic info on it, you'll see here that the relative DNS name is set to scalable-ase-demo, and that actually matches the domain name here under trafficmanager.net. So that's how we sort of registered in DNS and said, hey, we're going to be using Traffic Manager. You'll notice we're using the weighted traffic routing method, which is just basically a sort of randomized round robin. And you can sort of infer here that I have 3 different apps running on 3 different app service environments serving up instances of my web pages. And so sure enough, if I come here and go into the profile, and if I go to the endpoints collection and take a look at one of the entries, you can see that I've added one of the entries being this web front-end one with this rather long name. Now, if I pop up here into the browser, I can also, if I want to, go directly to that exact same address. Of course, in real life, you don't typically go out and tell your customers this really long, fully qualified domain name, which is hence the reason why instead we set up each of our app service environments within the single Traffic Manager profile. Now, earlier, of course, I created the Traffic Manager profile ahead of time, but just for reference that you can sort of see, hey, where did I get the information about this commandlet from? What are some of the various commands? I've pulled up here on the screen, first off, a reference into the Azure doc collection that has all of the details about the Azure Resource Manager commands for Traffic Manager. And I'm showing you 2 of the commands I use to help build and populate this profile. So you can see I'm using the new Azure Traffic Manager profile command. And again, there's my scalable ASE demo DNS name. So this is how I actually created the profile initially. And then what I did is I called this command, the add Azure Traffic Manager endpoint config command, to add each of my 3 individual app service environments. And sure enough here, I'm showing you the command where I added the first instance of my web app and my app service environment into the Traffic Manager profile. A couple of quick notes on this, because some of you have probably used Traffic Manager before. Because I'm using the newer ARM, aka Azure Resource Manager variation of Traffic Manager, for now I'm defining all of my endpoints as external. It will be coming in the not too distant future that we will be adding native support and awareness of Azure App Service endpoints. So in the future, you will actually have first-class support inside of these commandlets that recognize, oh, you're running a web or a mobile app, and you can just add it directly. But what I've done today is I've just said, hey, Traffic Manager, I've got an external endpoint, and then I'm just literally giving it the fully qualified AzureWebsites.net address of my app. And so I did that for my first instance, and I did that, for my third instance. So this is what the command would look like when I was adding my third instance of the app into the profile. So let's take a look at things from the perspective of the portal in terms of how I sort of set up these 3 app service environments. So I'm in the newer portal, and I'm drilling in here and saying, let's browse all of the app service environments that I have available on my subscription. And you can see here, I've got one app service environment in South Central, which is running my web API backend. But then for purposes of this discussion about how to scale out, I set up 1, 2, 3 instances of app service environments. And again, they're all in South Central US. And trying to do that today in sort of the general multi-tenant footprint of Azure App Service, for the most part, you can't really pull that off and accomplish it. But here it's very easy and deterministic. Every time you create an app service environment, you tell us what region you want it in, and you give us a unique name. So if you want 10 app service environments all in East US, you can go for it. If instead you want 10 app service environments spammed out around the world, no problem. You can do that too. So it's very straightforward to be able to get as big of a footprint as you want, both within a single Azure region as well as across multiple Azure regions. So I'll drill here into my first app service environment, and in the details blade, it lists out all of the apps that are actually running in that app service environment. And sure enough, you can see that I've got an instance of my app here. Here's Web Frontend 1. And you can also see how it's set up to actually serve this custom domain as well. And actually, if we drill a little bit further in and take a look at the details for all the custom host names that I've got set up, you'll similarly see how I've set things. So there's www.scalableasedemo.com, which ensures the fact that requests that get to this app will get served. And there's the sort of internal only, fully qualified domain name for my app. So that, in a nutshell, is how I was able to very quickly and easily set up 3 instances of my app all in the same region. And like I said, you can go ahead and have whatever footprint you're looking for. The one thing to always keep in mind, of course, is even though I'm showing you today how you can quickly spam out as many front ends, presentation tiers as you want, make sure that your back ends are similarly architected and structured to be able to handle that kind of scale out. Like I was mentioning earlier, both about sort of the voting style kinds of applications, as well as our own internal monitoring infrastructure, sort of one of the key things that those kinds of apps always do in the back end is they are relatively stateless. So it makes it very easy to scale out the presentation tier and similarly be able to scale out the back end tiers to keep up with it. Okay, so we'll drop back into the slides and move on to sort of the second big scenario that we enable with app service environments. And that one is all about secure access. So one of the really cool things that you get when you use an app service environment is you literally are running in a miniaturized version of Azure App Service. It's in essence built and dedicated exclusively for you, just for your apps, just for your subscription. So you're completely isolated and you don't have to worry about, for example, proverbial bad neighbor effects or shared infrastructure with other customers running on sort of the same set of compute resources. Now, the other thing that I had mentioned earlier was that every app service environment gets created inside of a virtual network. That's very important because when your apps run on an app service environment, they're not on the outside of your virtual network peering in and trying to sort of hook up through a little gateway. Every app service environment gets created inside of a virtual network, and you can make that selection up front when you create your app service environment. That gives you some very powerful security capabilities. So it gives you direct high-speed access to very sensitive back-end resources that you have deployed in the same virtual network infrastructure. And that can mean everything from an API or a database server running in the same Azure VNet, or it can mean resources that are sitting off on the other side of, for example, a site-to-site gateway. The other thing that you get, the other benefit, is because the app service environment always gets created inside of a subnet of a virtual network, you can use a very powerful feature provided by Azure Networking called network security groups. And that gives you a lot more fine-grained intentional control over both inbound network communications and the network communications that flow out the back end of your apps. What I'm going to show you today is one of the architectures that we've recommended to customers who are working on, for example, internet e-commerce sites and internet e-banking scenarios. And this is the one where you set up multiple tiers or multiple layers of security. And this Visio shows you very briefly the idea of setting up an app service environment that's internet-facing, and a second one that is not internet-facing. And what you can do is you can put the app service environments into different subnets with completely different network security rules on them, and you can basically lock down the second app service environment so that it only accepts network traffic from your presentation tier. And to show that to you in more detail, let's go back to our app and drill into how it's actually working behind the scenes. So again, remember that we have an MVC front end that's just showing some data, but this data that's on this page is actually coming from a completely separate app that was written using web APIs. So jumping in here real quick into Visual Studio, I'm in the solution for my web API project. Now, the project itself is very simple. It just happens to use Entity Framework against one of our myriad demo databases, in this case, the AdventureWorks database. And all I'm doing is I'm making a simple select statement out of that database. But the interesting thing, and we'll come back to it in a few minutes, is, hey, it's a database, and where is that database? Well, clearly in the code, I've got a completely bogus connection string. So keep that in mind because we'll come back to it a little bit later and explain A, how do we actually get a real connection string, and B, where are we actually pointing this API app at in the first place. So that's my API layer. Let's jump up to the web tier. So again, this is just an MVC project. And what we did is we pulled down the REST Sharp NuGet package just to give us a really easy way to write a C# wrapper around our REST API project that we were just looking at. You see that we set up the client and we point it at the URL of our backend API. And in this case, we're going to pull it out of the application settings that are associated with this app. And then I go out and I make a GET request. In this case, I'm saying, hey, go get me that sales territory list. So that's the list of info we were seeing on the web page. And as an aside, you can sort of see here off in the Solution Explorer, you notice how I've got web frontend 1, 2, and 3, and I've got the publishing profiles for all of them. That's how I went out, and in this case, spammed out 3 instances of my app up into the app service environments. I just created 3 instances of the app, downloaded the publishing profile for each one, and then just in rapid fire fashion went publish, publish, publish. That's sort of the most manual way of doing it, but it gives you the idea that once you have multiple app service environments, you will want to have a way to be able to push out your app into each of those. Okay, so we've seen what's going on behind the scenes in the code. Let's pop back up into the portal. And first off, let's go take a look at the app service environment for my API. So you can see here, this is my 4th app service environment, also running in South Central, and it's called API ASE. Sure enough, I've got one web app running on it, and if I click into it, it tells me, oh great, I'm running this backend API app. And here's the URL for it. Now, interesting thing about that URL is if I pop over here into the browser, and if I try to go to that API directly, what's going to happen is the browser is just going to spin here forever because that URL and that app happens to be running in a subnet where I've locked it down with a network security group. And you can see, sure enough, in this case, IE eventually times out and says, yeah, you can't actually get to that URL because, of course, I'm just sitting here on my laptop and I'm trying to reach it over the internet. So what I did earlier was that I set up a variety of network security group rules to lock down the subnet. So I'm showing you here in this second PowerShell window, I've dumped out the rules for the network security group that I created. And the interesting part is I've got 3 pairs of rules here that I'm highlighting. And you can see I've got allow rules that allow in HTTP and HTTPS calls. I have 1 pair for each one of my 3 app service environments. So you remember earlier that when we did the NS lookup on my machine, it happened to resolve to the web frontend number 1, right? So we can see here that we have a rule for the first app service environment. And look at that IP address, 6552.138. So that's going to be an interesting address to keep in mind because we're allowing inbound traffic if it appears to have been NATed and originated from that IP address. So let's pop back into the portal. Let's jump over to my first app service environment and similarly pop over to that web app. And if I drill into the properties of that web app, one of the things that the portal will show me, and you can also get this via the API, is it will show me what is my outbound IP address. And you can see right there, 6552.34.138. And so that's how we were able to lock down the API endpoint that's running in my 4th app service environment, and I only allowed access from the 3 outbound IP addresses that I have, 1 for each of my front-end web apps. And then the final piece of the puzzle is that whenever you create a network security group, Azure by default always has this catch-all deny rule. And so if I don't actually match any of the 3 NAT IP addresses for my app service environment, ultimately Azure is going to say, well, this packet, I've got to evaluate it against the default catch-all rule, and so I block access to it. And that is why when I try to go to the backend API endpoint directly from the browser, it just fails because the packets get dropped at the network boundary. That's actually a very important point that I wanted to highlight One of the very cool things about the network security groups is that when packets get dropped, they're getting dropped upstream of your app. So if someone is sitting there, a malicious actor, and they're trying to send packets to you, unless they match one of these rules, those packets are going to be dropped far upstream of your web servers, and you don't have to worry about the packets ever actually getting onto the web server in the first place and then burning up CPU time trying to figure out whether or not we should or shouldn't reject a request. So the one last thing I wanted to touch on was, that API app that I mentioned was talking to a SQL Server database. So let's see how we're actually able to do that. I'll click into my app service environment for my app. And once it comes up, it'll show me the list of apps that are deployed on it, and we'll drill into the properties of that app. And specifically, what I want to look at are the connection strings that I've set up. So we'll scroll down a bit, and we'll say, great, let's go show the connection string. We'll zoom in a bit and scroll off to the side here so you can see a little bit more, and you should see right there in the text box the IP address 10.0.0.4. So clearly, my web API app is not connecting to a public VIP. It's not connecting to, for example, a publicly accessible SQL database. Instead, it's connecting to an IP address that's coming from the address range of my virtual network. And furthermore, as you can see, it's a non-routable address, so it's not something that you can reach from over the internet. So how is that actually working? Well, I'll jump into the old portal here and drill into a virtual machine that I set up earlier. And this virtual machine is running just plain old SQL Server. And if we scroll down a bit and take a look at the internal IP address for it, you'll see, sure enough, 10.0.0.4. So this is meant to demonstrate the scenario of running some kind of secure backend database that's only going to be reachable over its internal IP address. And what happens is when your app in an app service environment makes an outbound call to another address that's within the virtual network address space, Azure recognizes that, and it will actually assign it a NAT that comes from the address range of the virtual network. And I've actually taken advantage of that fact by setting up an old school endpoint ACL on the port 1433 that's used by SQL. So you can see here, with the ACLs I've defined on my SQL Server database, I allow access if you're originating from an address range that's within the 10 dot address range, but I deny access for everyone else. And so again, because Azure went out and natted my internal VNet communications using a 10 dot address, my API app running on the app service environment is able to successfully connect to SQL Server. Okay, so those were the two scenarios I wanted to walk through with all of you today. And hopefully that gives you a pretty good idea of the two capabilities that we have with app service environments. Ultra high scale, so if you need to spam instances of your app all over the world, app service environments are the way to do it for your web and mobile apps. And then secondly, if you need secure high-speed access to your most sensitive backend resources, you can do that by running apps on app service environments inside of your virtual network infrastructure. So thank you for listening and have a good day, folks.